Welcome to this School Science. I am Tapan Sarma, present before you, trying to teach science lesson for high school students. Today, I am trying to teach science lessons for class 10 students. The topic is chemical reaction and equation, part 2. Already part 1 we discussed about chemical equation. So today I am going to start these different types of chemical reaction. Different types of chemical reaction. Types of chemical reaction. Today we are going to discuss different types of chemical reactions. So you see, this chemical reaction and equation, lesson number 1, class 10, this comprises of 3 parts. Already 1 part we discussed, 2 part, the types of chemical, like this 3 part also there. So you should download all these 3 part once, and according to your convenient time you can see part by part. For this, you please subscribe the channel and press the bell icon so that you will get continuous notification of my channel. Now come to this topic, types of chemical reaction. So there are different types. First of all, you see the mind map. Mind map, very important. This is mind map. This is mind map. Different types of chemical reaction. Combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction. So first we start combination reaction. Combination reaction. The name itself gives some idea what type of reaction it is. That means two or more reactants join together to form a single product, then this is called combination reaction. Okay, so for example, say carbon plus oxygen, it forms carbon dioxide. So this is combination reaction. Okay, another combination reaction, you see calcium oxide plus water. So what does it form? Calcium hydroxide. So this is combination reaction. Similarly, another reaction using magnesium react with oxygen to form magnesium oxide. So these are combination reaction with 2 or more reactants combined to form a single product. That is very simple. That is called combination reaction. But one important thing you see, this I have given arrow mark that combination reaction are exothermic reaction. Exothermic reaction means in this reaction heat evolves, heat releases. So here heat releases, and in this case these reactions are called exothermic reaction. So like this combination reaction. Next is coming. What is that? decomposition reaction. Decomposition. Number 2. This combination reaction gone. Now coming to decomposition reaction. Decomposition reaction. In this case, it is just opposite of combination reaction. It is just opposite of combination reaction. In this case, a single reactants break down, forming 2 or more product. Then this is called decomposition reaction. So, for example, so FeSO4. So in case of FeSO4, what happens? Fe2O3, SO2 and SO3. You see, here from a single reactant forming 3 different products, Fe2O3, ferrous oxide and sulfur dioxide, sulfur trioxide. So this is decomposed, breakdown. Another example of decomposition reaction you see, number 2, this say calcium carbonate. So what is formed? Calcium oxide plus carbon dioxide. Calcium oxide and carbon dioxide. So here also single reactants break down forming 2 products. Clear? This decomposition reaction, very simple. Single reactants break down forming 2 or more products. But one important thing you see regarding decomposition reaction, these reactions, heat is absorbed. That is why this is called endothermic reaction. Endothermic reaction. Thermic means temperature absorbed. That's why to make this reaction fast, we have to apply heat. Here also we have to apply heat. So whenever we apply heat, then decomposition starts. So based on this decomposition, there are three different types of decomposition reaction. By applying heat, by applying heat. So whenever by applying heat this decomposition occurs, then that reaction is called thermal decomposition reaction. Okay, thermal decomposition reaction. Besides this, this decomposition reaction occurs by applying electricity also. By applying electricity also. Okay, so for example, you see water. Electrolysis of water. Water, you see hydrogen and oxygen form. So that hydrogen and oxygen split by applying electricity. Okay, so electrolysis of water. This is called electrolysis of water. Another one by sunlight. With the help of light, this decomposition occurs. Okay. For example, you see silver chloride. So it is light. So what will happen? Silver and chlorine. So decomposition occurs by applying heat, electricity, sunlight. Are you clear? That means in case of decomposition, single reactant split into 2 or 3 products. Okay. Next is coming displacement reaction. You see displacement reaction. Next is displacement reaction. Displacement reaction. In case of displacement reaction, you see highly active metal displaces low active metal from its salt solution. Highly active metal displaces low active metal from its salt solution. In this, to understand displacement reaction, so you have to know activity series. Activity series of metal. Activity series of metal. Okay. So this activity series, you see sodium, magnesium, zinc, iron, copper, silver. So you should know like this: sodium, magnesium, zinc, iron, copper, silver. Okay, in so many metals are there. I make it 6 so that we can easily memorize it like a few: sodium, magnesium, zinc, iron, copper, silver. Okay, that means sodium is more active than magnesium. Magnesium is more active than zinc. Zinc is more active than iron. Iron is more active than copper. Copper is more active than silver. That means silver is the least reactive. It does not participate in chemical reaction since its activity is very less. Okay. So you have to know this activity, then you can understand displacement reaction. Okay. Without knowing this, you cannot understand. Okay, so displacement reaction example you see. One example I give you. Say example 1. You see iron. Whenever iron react with copper sulfate, you see one metal iron, another metal copper in this solution state. So iron is more reactive than copper. So iron will displace copper, forming iron sulfate. Copper will be reduced. Okay, copper will be reduced. So if you write this reaction in this reverse way, say copper plus iron sulfate. If we compare the activity of copper and iron sulfate is in the solution. So copper should displace iron, but copper is low active than iron, so it cannot displace iron from its solution. So ultimately, what will happen? No reaction will happen. No reaction. Understood? So, in case of displacement reaction, it is clear that one metal must be associated as reactant part. One metal, only one metal. One must be solution. Are you clear? So, this is called displacement reaction. After that displacement reaction, you see, another reaction is there. You see, this displacement gone. Then coming to double displacement reaction. So, in case of double displacement reaction, that means there will be exchange of ions between the metal part, exchange of ions. Okay, so for example, this double displacement reaction, you see, sodium sulfate as given in your book, sodium sulfate plus barium chloride, sodium sulfate, barium chloride. So sodium is metal and barium is metal. There is a competition between sodium and barium. So there will be exchange of ion. So sodium will come here, barium will go that side. Ultimately what will happen? Barium sulfate plus sodium chloride. Okay, barium sulfate plus sodium chloride. I am not balanced now. Balance already got in part on how to balance it. Simply I write this skeletal equation. So here you see, sodium displaces barium, barium displaces sodium, forming new compound. That is why 2 times displacement occur. That is why it is double displacement reaction. Okay. So in this product side, if you see these two products compared to sodium, you see, it is very important. Compared to sodium, very important. You see, compared to sodium, barium is less active than sodium. Sodium is very active metal, quickly react. That's why sodium chloride, whatever form, so this will remain in the solution. And which one is compared sodium and barium? Barium is low active metal, so it will be precipitate. It will precipitate. That means it will be deposited at the bottom of the vessel. So that is why this displacement reaction is also called precipitation reaction. Are you clear? So double displacement reaction, another name is precipitation reaction. That means in case of one important quality of double displacement reaction, one of the product must be precipitated. That is why it is called precipitation reaction. Okay. After that, we come to this oxidation and reduction reaction. Oxidation and reduction reaction. Oxidation and reduction reaction. Oxidation and reduction reaction. You see, we know one is oxidation reaction, another is reduction reaction. But whenever time is concerned about this chemical reaction, these written together. That means this oxidation reaction and reduction reactions occur together. Are you clear? So first of all, we know clear about this oxidation reaction. Oxidation reaction. So oxidation means reaction means addition of oxygen. Or removal of hydrogen. That is the meaning oxidation reaction. For example, you see. So carbon plus oxygen forming carbon dioxide. So in the reactant not carbon, but product side carbon dioxide. So you see, carbon transformed to carbon dioxide. So definitely it will be oxidation reaction. Are you clear? Next is coming reduction reaction. So reduction reaction is just opposite of oxidation reaction. So we can write removal of oxygen or addition of hydrogen. Okay, so this is called reduction reaction. For example, you see, ZnO plus carbon, ZnO, zinc oxide plus carbon. So it will form zinc plus carbon monoxide. Now you see, this zinc oxide transformed to zinc, no oxygen, there is removal of oxygen, so that is why it is called reduction reaction. Okay, now most of the cases, what is happening, both oxidation and reduction reactions occur simultaneously in the same reaction. Then that reaction is called, redox reaction. That is called what reaction? Redox reaction. You see, redox reaction. That is called redox reaction. That means both oxidation reaction and reduction reactions occur in the same reaction. That is called redox reaction. For example, you see, copper oxide plus hydrogen, CuO plus hydrogen. So what will form? Copper plus water. Now come to this. Now you see, this copper oxide transformed to copper, there is removal of oxygen. Previously oxygen is there, no oxygen. So what reaction will be it is? Reduction reaction, removal of oxygen. On the other hand, you see hydrogen, it is oxygen to form water, so there is addition of oxygen, so it is called oxidation reaction. So like this both oxidation reaction and reduction reactions occur in the same reaction, that is called redox reaction. So that is all about this topic today, part 2. Okay, so next part 3 we discuss about the activity related questions. Whatever activities there, most of the students do not go through this activity, then you cannot perform good in MCQ questions. So next part 3, in another video, we discuss about this activity related questions. Thank you.